Hello everyone. Yesterday we had seen the demultiplexer. The meaning of demultiplexer we had seen the multiplexer which is one line to n line multiplexer is seen in our yesterday's video lecture. Now we have to see the one line to 8 line demultiplexer. In last video lecture, we seen the logical diagram of one line to two-line demultiplexer, is it? So we drawn the logic diagram of one line to two-line demultiplexer. Then we drawn the logic diagram of one line to four line. It means 1:4 demultiplexer. Now we have to see the one line to 8 line demultiplexer. The one line to 8 line demultiplexer, first we draw the symbolical representation. So the to 1 line to 8 line means 1:8 demultiplexer is there. That 1:8 demultiplexer symbol is like this. The symbol is like the symbol of one line to four-line demultiplexer, only one change. What is that change? The change is only the number of the output lines. So this one line to 8 line demultiplexer having one data input. This is the data input. That data input we denote by using the letter D, and the 8 number of the output lines. The 8 number of output lines are there. It means here the first line is the Y0 line. The first line is the Y0 line. So here is the line, that is the Y0. Then second line is the Y1 line. This is the Y1 line. Third line is the Y2. Fourth one is the Y3. Then next one is the Y4. Then Y5. Y6, and last one is the Y7. So here this is the Y1 line, this is the Y2 line, this one is Y3, Y4, Y5, and Y6, and last one is the Y7 line. Okay, so these are the output lines. Instead of these output lines, you can use here D0, then D1 like this. Okay. So as we are using the data input is D, so we use the output as the Y output. Okay. So the demultiplexer which have one data input line, only one data input line, and 8 number of the output lines. How many lines? 8 number of output line. Here that demultiplexer is we call as one line to 8 line demultiplexer. This data line can be passed towards the output side. The data line can be passed towards the output side. Means the data can be passed over the output line Y0 or the output line Y1 or the output line Y2 or the output line Y7. That depends on the applied input code. That input code is we call as what we call it as a select code, means the select input code. Okay, so here the select input required, that select input we show at the lower side, and here the 3 select inputs we require. Why we require 3 select input? There is one formula that we had seen yesterday, as well as we had seen this same formula when we seen the multiplexer. Okay, so the formula is n equals to n is the output line, n equals to 2 is to power m. Yesterday we had seen the MCQ on this. What is that MCQ? The MCQ is the demultiplexer having the select input lines given by using a formula. That formula is n equals to 2 is to power m. Okay, so n is what? N is the output lines, and m is what? M is the select line. Okay, so how many select lines we required? As for this one line to 8 line demultiplexer, it requires the 3 number of select lines, and these 3 select lines are what we call S0 LS bit line, then next one is the S1, and the next one is the S2. These are the three select lines. Then one more input is there. That input is we call as a strobe input, and this strobe input is the active low strobe input. This input is the active low strobe input, and we denote the active low strobe input by using G oblique 8 is we also call as the enable. Okay, so if there is a question in examination, then they explain the working of one line to 8 line multiplexer, demultiplexer. Explain the working of one line to 8 line demultiplexer with the help of its logical diagram, its symbol, and the truth table. So what we have to do? All is specified in your question. You have to draw this symbol. This one is the symbol of one line to 8 line demultiplexer. Then you have to draw the logical diagram. Then you have to explain any two conditions, how the data is passed towards the output Y0 line and how the data is passed towards the output line Y7, or you can explain the three lines. Okay, so here the symbol is drawn. We require to draw the logical diagram, but what is the requirement to draw the logical diagram? To draw the logical diagram, the requirement is you must need the 8 number of the AND gates. How many number of AND gates? You require 8 number of AND gates. But why we require the 8 number of AND gates? We require 8 number of AND gates because the outputs are the 8. Okay, so we draw the logical diagram of the one line to 8 line demultiplexer. Okay, so I'm going to draw here the first AND gate, the second AND gate, and the last AND gate because of the space available here on the screen. But while I am drawing the logical diagram, you also draw in your notebook, so it gets easy for you. So here we draw the logical diagram. Okay, so here the one line to 8 line demultiplexer, one line to 8 line demultiplexer we have to draw, and one line to 8 line demultiplexer means here we require to use the AND gate. So here I am going to use the first AND gate. This AND gate having the output, that output is the Y0. Here it is the Y0. Then the second one is there. That second AND gate we are using, that AND gate having the output, that output is the Y1 output. Here is the Y1 output. Okay, this is the Y1 output. Now the last one AND gate I am going to draw. Then here we require to draw the AND gate. This is the last AND gate. Okay, so here at this last AND gate, the output is the Y7 output. Okay, now here the data line is required, and as we know, this demultiplexer having one common data line. This is having the common data line. So here is the data line D. I am going to denote it by using the data line D. Here is the data line D. This data line D is connected to all of the AND gates. This data line D is connected to all of the AND gates. So here is the connection of the all inputs. So here is the input connected to the last AND gate. Then here it is connected to the second AND gate. Means here is the connection. Okay. Now, while drawing the logical diagram, you draw 8 number of AND gates, not only one AND gate or 3 number of AND gate. I am going to draw here the 3 AND gate. Okay, I will draw the 8 number of AND gates. So you're not having any confusion. So here is this one. This is here one AND gate. That AND gate is the third AND gate having the output Y2. Then one more AND gate is here. That AND gate having the output Y3. Okay. Then here we require to draw the remaining AND gates. These AND gates are for the Y3, Y4, Y5, and Y7. So here it is the next one AND gate. That AND gate is having the output. That output is the Y4 output. Then next one is having the output. That output is the Y5 output. Okay. So here we require the 8 number of AND gates. The 8 number of AND gates we require to draw. So I am going to draw here the 8 number of AND gates. So here is Y5 output, then Y6 output. For Y6 here, one more AND gate we required, and for Y7 here is the Y6, and last one is here the Y7. Here is the Y7. Okay, so this is the structure, or we can say the construction of the all AND gates. So here is the connection. This is the data line connected to each of the AND gate. Here is again connection. Here is the connection. Then here we connect the input. Here for the data line, for the gate Y3 data line is connected, and here this is the connection for the all of the AND gates. Okay, now what to do after this? After this, here we require to make the other connections. What are the other connections? Here the all AND gates having the data, then the all AND gates having the output. After that, here we require to connect the select lines. Okay, so for select line we require to use the 3 select lines. The 3 select lines are S0, then the S1, and the S2. S0, S1, and S2. With these 3 inputs, one more input we require. What is that? That input is this probe input or the enable input. Okay, so I'm going to draw here the enable input. For that input, here we draw one line at the lower side, and remember this input is the active low input. So for that, here we apply one NOT gate. Okay, so here is the NOT gate. That NOT gate having the input, that input is we call this probe input G oblique E. Okay, now this is the connection of this probe line. So here it is connected to the all of gates, all gates. Okay, so here it is the connection of the all gates. Now we require to apply the select input. So for this select input, here we have the first line. This line is the S1 line. Okay, we have to draw one more line. That line is the S1 line. That line is we call as the active low line. This is the active low line. Okay, then here we require S0 line. First line is the S2 line. This is the S2 line. Second line is the S1 line. Here it is the S1 line. Then again we require one more line. That line is we call the inverted line or the active low line. For that, here we use the NOT gate. Okay, so these two are the input lines. Then one more line we require for the select input S0. So here it is the line. That line is the S0 line. Here it is the S0 line. Okay, so this line is the S0 line. Then inverted line we required. So that line is we call the active low line. Here it is the active low line. For the active low line we require to use the NOT gate. Okay, so these are the connections for the all AND gates. These all AND gates having the connections. Now here this input is the S0 input. The inverted line input is the S0 bar input. The inverted line of the S1 is the S1 bar input, and inverted line of the S2 is the inverted S2 bar. Okay, now as per the truth table we require to make the connections. If in truth table, the truth table is as per our need. In truth table, what we put, we just use the select inputs and the output selected. I am going to draw here the truth table, and as per the truth table, we make the connections. Now here, the in truth table, we use the select input and the output selected. The inputs are S2, then S1 and S0. These are we call select input, or the select lines, or we call it as the control input that controls the passing of the data over the output line. So it is we call as the control input. Then here at this side, what we required? We required the output. Actually, it is the output selected. We write down the output selected. Here is the output selected. Okay. Now, here the entries are there. The entries are the S0, S1 and S2. Here it is S2 equals to 0, S1 equals to 0 and S0 equals to 0. See, the first control input, first select code we apply, that select code is the 0, 0, 0. Then it is desired the data is passed towards the output line. That output line is the Y0. Means only the Y0 is equals to D, and the remaining output Y1, Y2, Y3, Y4, Y5, Y6 and Y7 are equals to 0, 0. So therefore here the output selected, that output is the Y0, and remaining all output is equals to the 0. Okay. Now here the second input we apply. Second input is 0, 0, 1. When we apply this second input code 0, 0, 1, at that time it is desired that the output Y1 is selected. So for that here, what type of connections we have to make in our logical diagram? In our logical diagram, we have to make the connections, and that connections are like this. What connections we have to make? We have to make the connections of this select code to each of the AND gate. Okay. So for that here, we make the connections. What connections we have to make? Here we have to apply the select codes S2, S1 and S0 to the each of the AND gate. But for the first AND gate, we require to apply the input as the input codes available in the truth table. Okay. So wherever there is a low input, where there is a 0 input in the select code, for that particular gate, we make the connection as the active low connection. What it means? It means here to get the output Y equals to D, to get the output Y equals to D, we require to make the connection as S2 bar, S1 bar and S0 bar. Okay. We are applying the select input as S2, S1 and S0. So we apply the input to the AND gate are S2 bar, S1 bar and S0 bar. Why we apply this? Because when the select input S2, S1 and S0 all are equals to 0, at that time S2 bar equals to 1, S1 is 1 and S0 is 1. So therefore here we get the output Y0 is equals to Y0 is equals to data input D. Okay. So here I am going to make the connections. For that here the S1 bar I am going to connect. You also make the connections like this. Yes, S2 bar, then S1 bar, and last one is here S0 bar. Okay. So these are the connections for the first AND gate. I am going to write down at the output of this AND gate. The connections are the data input D. The connections are data input D, then S2 bar, S1 bar, S0 bar, S2 bar, S1 bar and S0 bar. Now see, if we apply the input as S2 equals to 0, S1 equals to 0 and S0 equals to 0, what we get? S2 bar equals to 1, S1 bar equals to 1, and S0 bar equals to 1. Means the output Y is equals to what we get? Output Y is equals to D dot 1 dot 1 dot 1. Means the output Y is equals to D. Is it? So here when we apply the select input as S2 equals to 0, S1 equals to 0, and S0 equals to 0. It means here S2 bar equals to 1, S1 bar equals to 1, and S0 bar equals to 1. So we get the output. That output is Y0 equals to data input D. It means here the data input is passed towards the first line, and that line is the Y0 line. What about the other lines? Here at the other line, we get the output Y is equals to 0. Okay. Now we apply the second input. The second input is 0, 0, and 1. Second input is the 0, 0, 1. Means here the S2 is equals to 0, S1 is equals to 0, S2 equals to 0, S1 equals to 0, and S0 is equals to 1. Then it is desired that the output selected is the Y1. It means here now the Y1 is equals to data input D. Means here Y0 is equals to 0 and all other line is equals to 0. For that here we have to make the connection as for the second gate here to make the connection as the S2 bar. What we have to make the connection? S2 bar, S1 bar, and S0. S2 bar, S1 bar, and S0. Sorry. We apply the select input as 0, 0, 1. S2 equals to 1 means S2 equals to 0 means S2 bar is equals to 1. S1 is equals to 0 means S1 bar equals to 1 and S0 is equals to 1. And here the connection is the S0. So here we get the output. That output is Y1 equals to data input D. See the inputs for the all AND gate having the data input. Okay, so data input D, then S2 bar, S1 bar, S0, data input D, then S2 bar is equals to 1, then S1 bar equals to 1 and S0 is equals to 1. So we get here the output Y is equals to D. It means here when we apply the select code 001, here we get the output. That output is the Y1. It means the data is passed towards the output Y1. So like that here we have to make the connection. For the second gate here we apply S2 bar. Okay, with me you apply the inputs means you make the connections. I hope all of you made the connections before me. So here the S2 bar we apply. The first line is the S2 bar. Then second line is the S1 bar. Here it is the S. Here it is the S2 bar line. Okay. So here I am going to make the connection with the S2 bar. Then second line is the S1 bar. Here it is the S1 bar line. Okay. Then next line is the S0, not S0 bar. We use the S0 bar in the previous case when we can make the connection of the first gate. Okay. So here it is the S0. Okay. So these are the connections for the second gate. Now the third entry is there. That is 0, 1, 0. Here it is desired the Y2 line is selected for the data. It means here the out data line D is passed towards the Y2, and for that here we require to make the all AND gates in the disable condition. Already when we apply the input as 001, 010 means S2 is equals to 0, S1 is equals to 1 and S0 equals to 1. We make the connection as here. What are the connection? S2 bar, because here there is a 0. If there is a 0 in a truth table, you have to connect the inverted line of the select input. That is we call the active low line. Okay, so here it is the S2 bar, then S1 and S0 bar. Okay, I am going to write down here at the truth table. S2 bar, S1 and the S0 bar. Now, here we make the same connections for the third gate. S2 bar, here it is the S2 bar, S2 bar, the second line, S2 bar. Then next one is the S1, here the third line is for the S1. Then next one is the S0 bar, the last one line is the S0 bar. I am writing here the inputs S2 bar, S1 and S0 bar. Okay, so likewise we have to make the connections. I am going to directly write down the all inputs in the truth table. Accordingly, you make the connections. For the third entry, we have to apply 0, 1 and 0. Then the output line Y2 gets selected. When we apply the next input, it is 0, 1, 1. For here 0, 1, 1, what we make? The input. What connections we have to make? Here I am going to write down S2 bar, then S1 and S0, is it? So here the output line Y3 is connected. For the next entry, the inputs are 1, 0, 0. Then the Y4 is selected. And when we apply the select code 100, we require to make this gate only in enable condition having the output Y4 and remaining all gates in the disable condition. Okay, so here 100, it means for this gate the inputs are S2, S1 bar and S0 bar, because here 00 is there. If there is a 00, it means we require to connect the inverted line. So here S1 bar line we have to connect and S0 bar line we require to connect. Okay, the next entry is 1, 0 and 1. At that time the Y5 line will be selected. 101 means the inputs are S2, S1 bar and S0. Okay, then the next entry is for 1, 1 and 0. Then the line Y6 gets selected. 110. What are the connections? S2, S1 and S0 bar. Okay. Now the next one. The next one is the 1, 1 and 1. Then here the Y7 line will be selected at the output side. So here we can make the selection of data line towards the any of the output line. So when we apply the select input, that select input is the 000, then the output Y0 is equals to data line D and remaining all are equals to 0. It means remaining all AND gates are in disable condition and only the Y0 line is in enable condition. Okay, now if we apply the select input as 001, at that time the data line is passed towards the output line. That output line is the Y1, means Y1 is equals to data line D and remaining all are equals to 0, means only the second gate is in enable condition and remaining all AND gates are in the disable condition. If we apply the select input, that select input is the 010. At that time only one gate is in enable condition and that gate is the third gate, and here the data line D is passed towards the output. That output is the y2 means y2 is equals to d, and the remaining all output is equals to 0. Okay, I will provide the clear and neat diagram of this one line to the 8-line demultiplexer in our group, or I will provide the whole post in the website. Okay, so website article you have to see here, and in that website article you get the complete working of the demultiplexer. Okay, so this is the demultiplexer. Once again we will see what we have to write down in the examination. The question is, explain the working of one line to 8-line demultiplexer. In short, we say it is a demux. The first you have to write down the meaning of one line to 8-line demultiplexer. The meaning is the one line to 8-line is one line to 8-line demultiplexer is a demultiplexer having the 8 number of the data lines. It have the 8 number of the output lines and only one data line. Only one data line is there. The data line can be passed towards the output side from y0 to the y7, anyone at a time. The data line can be passed over the output lines y0 to the y7, anyone at a time, with the help of the select code, with the help of the select line. So when we apply the select code 000, then the first line is selected, and when we apply the select code 111, then the last line is selected. As per the truth table, we require to make the connections. Now, after this here, what we have to do? We have to write down the construction. When we write down the construction here, we require to use the 8 number of the AND gates. How many AND gates are there? We require to use the 8 number of the AND gates. So we write down the first line as the data input is applied to the each of the AND gate from the 8 AND gate. One more input is the common input. That input is we call as the probe input or the enable input. This probe input or the enable input is that input which makes the whole demultiplexer is in enable condition, or the whole demultiplexer is in the disable condition. So when we use the probe input equals to 1, when this probe input is equals to 1, it means the demultiplexer is in disable condition. When this probe input is equals to 0, it means the whole demultiplexer is in the enable condition. Okay, means there is enabling and disabling. The demultiplexer is in active mode or in deactive mode. That depends on this input, and this input is we call as a probe input. Okay, now after this here we can write down in construction. It requires the 8 number of AND gates, and each of the AND gate having the data input. Means here the data input is the common input for the all number of the AND gates available, and here the 8 number of the outputs are taken from each of the AND gate. Means the first AND gate having the first output and the last AND gate having the last output, that is we call as a y7, as we had seen in the diagram. When now we have to write down the working. The working can be explained by using the 2 or more conditions. 2 conditions are enough, because here the question is asked only for the 4 marks or for the 3 marks. When it is asked for the 4 marks, then we write down the working by using the 3 conditions. These 3 conditions are taken from the truth table. So here we can write down when the select input is applied. When the select input is applied, the select input is applied by using the select line S2, S1 and the S0. When the select input S2 is equals to 0, S1 is equals to 0 and S0 is equals to 0, At that time, here only the first AND gate is in enable condition and the data is passed. Sorry, the data is passed towards the output line y0. It means the output line y0 is equals to d. At that time, the remaining all AND gates are in the disable condition, only the first AND gate is in enable condition. Then you can use the second input condition, and that second input condition may be the last condition. S2, S1 and S0 are equals to 1, 1, 1, or you can use the other condition. So we can write down for this condition, when select input code S2, S1 and S0 equals to 1, 1, 1, then only the last AND gate is in enable condition and remaining all AND gates are in disable condition. All AND gates are in disable condition. So the output y7 is equals to d, and from y0 to the y6 line is equals to 0, because all these AND gates are in disable condition. The remaining one paragraph you can mention for the remaining line. For the remaining inputs 0, 0, 1, 2, the 1, 1, 0, the output selected are shown in the truth table. Then you can draw the truth table, and as per the truth table, you can make the connection and you can write down the equation for these first two inputs. Means for the first AND gate, the equation is y0 equals to d s2 bar, s1 bar, and s0 bar. For y7, it is d dot s2, s1, and the s0. Okay, so this is the construction and working of one line to 8-line demultiplexer. Three things you have to keep in mind for the construction of the 1-line to 8-line demultiplexer. For the construction of 1-line to 8-line demultiplexer, you require to use the 8 number of the AND gates. How many AND gates? You require to use the 8 number of the AND gate. The output of each of the AND gate is considered as the actual output. The output of the first AND gate is the y0, and the last AND gate output is the y7. Then only one data line is there. That data line is the common for the all of the AND gate. Means the data line should be connected to the all AND gates. Okay. Then the third is the strobe input or the enable input. The strobe input is the active low input, and it is connected to the all AND gates at a time, so that here all AND gates can be enabled and all AND gates can be disabled at a time. Okay. Now, one more thing we have to keep in mind when you write down the working here. Before working, you can draw the truth table, and while you are making the connections in the logical diagram, first you draw the truth table. Suppose the entry in truth table is 0, 0, 0. It means here for this gate having the output y0, you must make the connection as s2 bar, s1 bar, and s0 bar. Okay, means where there is a low input in the select code, for that AND gate you have to apply the active low line select input or inverted line select input. Okay. Now, for if the input is 1, 0, 1, it means here you require to make the connection for this particular gate is S2, S1 bar, and the S0. When there is a 1 in the code, it means here the direct line, that, or we call it as active high line, must be connected to the input. Okay, so these three things you have to keep in the mind. Next time we'll see how we can make the construction of the higher order demultiplexer, as well as we will say how we can use the combination design of a combinational logic circuit by using the demultiplexer by using the demultiplexer. Okay.